All right, I'm going to talk a little bit about why we need switches and what the difference between a switch and a router is. So, in the early days of computer networks, you had a shared line, the thick Ethernet. It was a bus style network. So, you had all of these computers that were connected to the same line, and they would send messages back and forth. Let's just call this A, B, and C. So if A wants to talk to C, it sends a message over. But if B wants to talk to A at the same time and they transmit at the same time, it creates a collision condition. Both messages get mixed together. Neither one's intelligible, and so they have to back off and start again. So the bus style networks worked great until you started adding on D, E. See, we got the new laser printer in, and everybody wants to use the laser printer, right? And so more and more people started joining our network. F, G. So when there was just a few people on there, it tended to work just fine. But as the network grew and more devices trying to share the same piece of network media, you got too many collisions, and then eventually the whole thing breaks down. So what we figured out is this line is called a segment, okay? And all of these computers are on a shared segment. So that was the first Ethernet, but they put a hub device in, and it was the same principle. So it behaves just like the bus network that we just saw. Okay, so here's A, B, C, and let's go ahead and hook up a printer, right? And as long as it's medium use, everything works good. But as soon as you start adding in more and more devices, the chances for collisions go up and up and up. And I had a network that was kind of like this. It had a bus network, and this hub was actually connected in. And so it got easier and easier to add more and more computers to it. Everybody was happy because we got to share these laser printers. You might hook a server on here, a file server to save our data. Everybody was just loving the power of the network, but it just eventually started to collapse on me. It got so busy that the thing didn't work right anymore. So what we needed to do, and that was the thing I didn't fully understand because I was new to networking, was that I needed to get devices onto their own segment. Make sure that they weren't all on the same shared piece of media. So the first thing that we did is I just switched that hub out. So I pulled that guy out and I stuck a switch in instead. Okay, I just stuck it right in place of it. All right, so now I've got a switch, and these were not inexpensive, by the way. Because of their power. So what happened when I put the switch in, and you have all of these devices going, now what the switch does is it takes note of who's on here. So D, let's just put if these are my abbreviated MAC addresses, right? The switch pays attention to what port everything is. So port 1, port 2, and so on. So as A talks to C over here, the switch notices, all right, A is sending a message to C, and it came in on port 1. So it builds a table, right? So what port is it, and what device is it? What's the MAC address? So it looks something like this. A sent a message to C. It didn't get to C yet. C hasn't said anything, but I did get a message from C, and it came in on port 1. So I can write port 1. I know that A is out there. And then when C replies, I'm barely reading my writing. It's on port 5. So C answers back to A on port 5, and the switch, that's where C is located. So on port 5, I have an address called C. So as these conversations go on, eventually the switch will have a note of where everyone is located. And we didn't start out putting each person individually on a port. The switches were so expensive that I only had one to start with. So what I wound up doing was putting like I'd take that server off of here, and I'd put the switch in, and I put my server on there. Okay, so that way it's on a segment all by itself. But I needed to get a few other people off of there. Oh, the other thing that we did too is we hooked up the internet eventually, so our ISP was coming in the cloud, I guess it was, and get hooked in there on the end as well. So as soon as we did that, that was kind of the straw that broke the camel's back, because everybody was sending traffic to that. So again, we disconnected it from the bus network. We ran it over to the switch, and now, as people are trying to get to the ISP or to the server, or we put printers on here, now we're breaking things down. But again, I needed to put in some smaller switches, get rid of the bus altogether, and ultimately I wanted to go for this kind of situation where everybody's on its own port on a switch. Okay, but I had quite a few, but basically if I could get half of these guys off of here and maybe put a switch, like take A and E off, they're in the same room, and just run wires to a switch this way. And then instead of hooking this switch to the bus, go ahead and run it to this other main switch back like that. As soon as I started pulling guys off of the bus and hooking in switches or even little hubs, but creating little sub-networks, pretty soon I've got fewer devices on the backbone here, and it ran a lot better. But ultimately what you're after is if you can get all of your computers and devices on a network to have their own port on a switch, eventually you'll get no collisions at all. The switch is the device that eliminates or reduces collisions because of this port and MAC address learning process. Eventually, it only sends traffic out where it needs to go. With the bus network and with the hub style of network, everybody sees every single frame that comes across the line, whether it's relevant or not. So the switch is a nice way of cleaning up your network.